Next, we have Damya Souami, sorry, pardon my American accent, who is going to tell us about probing solar system rings and atmospheres using WIRCam.
My name is Damya Souami. I'm CNRS researcher at the Observatory of Paris. And I just wanted to mention here there are two names that are underlined for students, Liam Roland, who did his master thesis last year with me on Neptune data, which I'll be presenting now, and Christian Pereira, who actually finished his PhD thesis on some of the data I'll be presenting now. So first of all, I'd like to start by saying thank you, mahalo, to the CFHT community, to the summit, to all of this amazing team that supports us on the ground and who is willing to answer some really delicate requests. So thank you. And thank you to Gaia, because obviously without Gaia stellar catalogs, none of this that I'm presenting today would be possible. So this is the structure of my talk. As I said, there will be two results. And actually, overnight, after listening to the talks yesterday, I've decided to change a bit the angle of my talk and not have it focused on the science results, but more telling the community and the SAC of how important and how crucial WIRCam is to this kind of science and how it is actually the only instrument on Earth that can achieve some of the results that I'll be mentioning here. So first of all, what is a stellar occultation? So basically a star being occulted. This is not transit, although the principle is the same, simply because the star is outside of the solar system and the object is within our solar system. It's called transit when it is within the same system. So here, an example of stellar occultation. This is an animation. That's why I'm using this laptop, because it's not working here. So the star is occulted here by the main body, and then it reappears and occulted here again. There is a little dimming detecting a ring. So stellar occultation allows us to detect these types of rings and probe them. And the thing is that until a bit over a decade ago, it was thought impossible to have rings around small solar system objects. So this is the spherical. This is the first ring system that was discovered around small solar system objects. And since then, there have been two other discoveries of rings around small solar system objects. And actually, one of them was done by CFHT. And I will get back to that just in a bit. But my point is that only about 30-ish small solar system objects have been probed to date by stellar occultations, and we already have so far 3 confirmed ring systems. That's 10%. That's pretty decent, and it's expected to go up a bit of spoiler a bit soon. But the thing is that imagine with LSST, and I'm anticipating here by conclusion, the number of objects it will be able to detect and probe. That being said, let's go back to Neptune. So NOC 21 stands for Neptune Occultation Campaign 2021. Why is it we were interested in Neptune, and we still are? Well, we've been talking yesterday about mini Neptunes, sub-Neptunes, etc. But the thing is that our own Neptune in our own stellar backyard is still holding many secrets from us. It has only been visited by one space mission. It was flyby by Voyager 2 in August 1989, and so many questions remain open. And the thing is that this figure, I'm not sure if you can see it clearly, people, I guess, on their screens can, but here in the room, so this is basically the path, this is the Milky Way projected into the sky, and this is the path of Neptune in the sky, going from 1975 until 2050. And here in red, this red arrow points towards 2021. In the 80s, Neptune was passing in front of the galactic center. There were many occultations. That's how the rings of Neptune were discovered. The arcs of Neptune were discovered because they're incomplete ring structures, arcs, material confined along the outermost ring. And then it's moving now in a region depleted of star. And that's been the case for quite some time, since the 90s. But thanks to Gaia, despite of the fact that it's not passing, it's in a region depleted of star, we are actually able, the Gaia stellar catalogs allow us to actually go and look for these occultations. And that's what we did here. So there are many motivations to do so, probing the rings and the atmosphere. The rings, why? Well, yesterday we had a nice presentation about the Saturnian system and satellites. So the thing is that these ring systems are evolving over time. There are small interactions with small satellites. As I mentioned, there are clumps of material arcs. Are they stable? Are they not stable? Well, they've been more or less stable-ish, although 2 of them have disappeared. But the point is that we want to understand the origin of these rings, their dynamical evolution over long and short time scale. And moreover, the stellar occultations provide a very high spatial resolution, basically at the kilometer level, at a distance of Neptune, which is at 30 UA. Just from ground, from using a nice telescope on ground with a nice camera. In terms of the atmosphere, so it will allow us to probe the stratosphere of the planet, and whatever information we get from these temperature profiles is actually not redundant. And someone yesterday was saying how they are struggling to explain to people that James Webb does not replace what we do on ground, and no, it does not. It's actually complementary to what we are able to do with these occultations in terms of probing the atmosphere. And another thing is that you send space mission, obviously Voyager was just a flyby, but let's say you send space mission, it has limited lifetime. And the thing is that this we're allowed to probe and study the evolution over longer time scales. That is until hopefully we get someday another mission to Neptune, which does not seem to be happening very soon. With that being said, this here summarizes this, in blue summarizes the occultation circumstances in terms of magnitude. I'm not going to extend on that. They are written here. But basically, all I want to say is that, as you can see, Neptune is very, very bright. And for this type of occultation, we need to go in the infrared. We need to turn off Neptune as much as possible. Moreover, we have to go to the K-band, and that restricts the number of instruments that can actually on Earth achieve that kind of thing. Moreover, we need the fast near-infrared camera because we want high spatial resolution. That, at the level of our instrument, means a high time resolution. And that also narrows down the number of instruments that exist on Earth. And we want very high time accuracy. Therefore, WIRCam is actually the perfect instrument. So this is the campaign. This is all the data sets that we have received. All the Southern Hemisphere telescopes were clouded out for that event. Basically, this is the map, and this is WIRCam. As you can see here, the exposure time, this is the highest time resolution we had for this data set. But the exposure time itself does not make it the best data, but this combined with the other thing make it the best data set. So this is the big campaign night. This is the CFHT observing room. You can recognize some people. There is Laurie and some other people here might recognize themselves. And we were in Meudon observing from the meeting room. And this is an animation made by Tom Vermeulen from CFHT. Basically, the event itself is about an hour and a half. This is obviously accelerated. This is Neptune, the star, and the sun. And now the star is going to be occulted and eventually reappear. So these are light curves photometry that were actually extracted by Liam, my student. So this is for the occulted star in blue. And these are reference stars. As you see, there are some fluctuations, but they're not correlated. It turns out we're looking into more details. So the thing is, looking into this, we need to model here the contribution of Neptune and try to remove it as much as possible to have the cleanest light curve and to be able to extract the best timings. And what you see here is actually not noise. These are spikes. These are real. They reflect actually the gravity wave activity in the atmosphere of Neptune. And what we did as well, I'm speeding up because I want to get to my conclusion. So these are all the cores. So this is the ingress for the event, how it translates into the plane of the sky. This is the egress. And the red line here is CFHT, and it's a bit off compared to that edge of the ellipse. And that that little bit of segment off tells us we have to introduce a correction to the ephemeris of Neptune. So these are the results, and I have to skip because I have 1 minute, but I will jump to Quawar. So jump into the results. So we discovered, thanks to CFHT, WIRCam here, along with other telescopes, that there was actually a second inner ring outside of the Roche limit of Quawar. And these are the past observations. There's Pluto, Neptune, Quawar. There are more to come. This is in 85, the first detection after the discovery of 84 of the arc of Neptune, which was done actually by CFHT. That was obviously before WIRCam. And there is a very, very bright future ahead of us with all the upcoming occultations by Uranus in the early 2030s, late 2020s here. There are more events to come by Neptune, and there's obviously the LSST discoveries of TNOs, which are just going to boost the number of events by TNOs. And I just want to say to the SAC, please keep in mind, do not put WIRCam aside. Keep in mind that we might need it for targetable opportunity events. And what it does here is groundbreaking science. And this is, I'm saying this because I've tried many instruments so far, as there are very few of them on Earth. And this is by far the best one on Earth. Thank you.
Thank you. Thank you very much for this interesting probe of the outer systems. Yes, Wesley.
And what makes you consider results that is to this follow the same sort of different evolutional process that Hypnos and John?
Thank you. Thanks. Yeah. So basically, the question was, if I compare to the 80s occultations and to the 2021 occultation, what has, I'm rephrasing, what has basically changed in the Neptunian system? One thing I did not get to mention because I was speeding up is that basically from the atmosphere standpoint, one season on Neptune is about 41-ish years on Earth. And that's actually one of the motivations that drove us in terms of a pure atmosphere science. But I, for one, am interested in the rings. Most importantly, rather than atmosphere is secondary to me. And in terms of rings, I mean, to my expertise, I'm more ring person. And therefore, in terms of rings, the star was actually too faint, was 13.1, but we tried. The point is that we tried because all these stars they had in the 80s, it was passing the galactic center, it was 7-8 magnitude stars, 9 magnitude star. So we attempted this one, and we got amazing results on the atmosphere, and we corrected the astrometry. And that was the big win. Papers in preparation.
Okay, thank you very much.